Okay, hello everyone. This is Dmitriy Sergeyev of Bocconi University speaking. First of all, let me thank the organizers for including this paper in this great conference. It's a great pleasure. Super interesting presentations today and yesterday. So this is joint work with Yuri Gorodnichenko of the UC Berkeley. And let me start by talking about deflation. So a modern history of deflation starts in the 1930s during the Great Depression. And macroeconomists and policymakers learned a great deal from this episode. And perhaps one of the most important things that this macro and policy people learned is to fear deflation. And then this experience in Japan, where the zero lower bound has been binding for almost 3 decades, reinforced this view. So, and perhaps because of this fear, the policymakers around at least advanced countries reacted with all tools possible, what we now call unconventional policies during the Great Depression and COVID-19 pandemic. And there is, in fact, a lot of support to at least some of these unconventional policies from the standard macroeconomic models, where, for example, inflation depends on future inflation expectations. And in particular, in models where agents have full information, rational expectations, this feedback between inflation and inflation expectation can be so powerful as to lead to this super devastating deflationary spirals. However, there is growing literature that suggests that people do not actually have full information, rational expectations. And so this brings us to this question: should we be worried about deflation as this modern models predict? And in this paper, what we do, we document a new fact, which says that households essentially never expect deflation. Moreover, there is some evidence that firms do not expect inflation either. We will call this a zero lower bound on inflation expectations. And taken literally, this constraint on inflation expectation implies that these strong forces that can produce these devastating deflationary spirals, they're not so strong. And perhaps this may explain that we avoided episodes of deflation during the Great Recession. More specifically, this presentation will consist of 2 parts. In the first part, I will show you a lot of the evidence that supports this view that there is this zero lower bound constraint on inflation expectations. I will show you cross-sectional distributions of inflation expectations for different countries, their time series behaviors, some conditional evidence. I will contrast how different groups of people, whether like all groups of people have this constraint, and I will also try to check whether this constraint applies to other variables. And then in the second part of this presentation, I will just take this constraint, insert it in the standard 3-equation New Keynesian model, and we'll derive a few predictions, and 2 of which will be you can explain missing disinflation, and the second, unconventional policies are not as powerful as in the standard models with full information rational expectations. Okay. So one way to look at the evidence that support this view that this constraint exists is to look at the cross-sectional distribution of inflation expectations. And here I show you this histogram of inflation 1 year ahead inflation expectations in the US from the Michigan Survey of Consumers between 1985. This is when the inflation rate in the US went down and became stable after Volcker's disinflation, and at the end of 2007, just before the start of the Great Recession. And so one striking observation here is that this distribution is skewed. And more importantly, there is almost nobody who expects deflation. And what is also interesting is that during this period, inflation actually never went down below 1%. So this red histogram presents the empirical distribution of realized inflation. So what it says, if you compare these two histograms, is that households are pretty capable of expecting something that doesn't happen, at least during this period. Let me move forward in time and show you the same histogram from the same source, but from the start of the Great Recession to April 2020. So the same pattern repeats itself. Almost nobody expects deflation in this survey. And this is at the time when actually realized inflation went a little bit below zero in the US. In some other countries that I will show you later, it went deeper and for longer, but so I wanted to start from the US. So this is, in a nutshell, our key fact. So what I will do next, I will present you some additional results coming, evidence coming from different countries, as well as time series evidence and some conditional evidence. And of course, my presentation would not be complete if I didn't show you Japan. Japan has been at the ZOB since 1994, and roughly 50% of the time since 1994, Japan was experienced deflation. So what I will show you is the data from the from Banque of Japan's opinion survey. So they actually ask a numerical question. It just we obtained the data in these beans. So we'll show you the beans, but I think these beans speak for themselves. Almost nobody in this survey, which runs between 2004 and 2020, expects deflation in Japan. And let me put the histogram of realized inflation. So here, more than 40% in this period, more than 40% of quarters featured deflation. Now, let me teleport you to the Netherlands. So we found an interesting question in the Dutch National Bank household survey, which asks households about their forecast of the minimum inflation in the next 12 months. And so this is the data between 2003 and 2020, and this is the histogram of their responses. And yet again, but here is about smallest inflation. Almost nobody expects the smallest inflation to be below zero. Okay. Now, so far I have been pulling all the time series dimension, and I was presenting these histograms. Now I want to show you how these histograms behave over time. And for the purpose of diversity, let me show you Greece. Why Greece? Well, we all know that Greece experienced this devastating episode during the European debt crisis. Unemployment rate went higher than 30%. And so what is less known is that Greece experienced 4 consecutive years of deflation between 2012 and 2016. So we take the data from the European Commission Business and Consumer Survey, and so let me show you the data. So the top panel just presents inflation and core inflation, and you can see for yourself that there was deflation between 2012 and 2016 for consecutive years. The bottom part presents the time series evolution of the fraction of people who expect negative inflation, red line, zero inflation, yellow line, and positive inflation, green line. And so the key observation here is that red line is kind of small, and it barely moves. Again, supporting this view that there is perhaps this constraint on inflation expectations. Of course, there was this episode around 2008, 2009. This is probably the global financial crisis, when the fraction of people who expected deflation started going up. I'm not super sure what it is. Perhaps it is due to behavior of some salient prices. Like, for example, during that period, oil prices collapsed from $1960 per barrel to around 50 or 60. But what's interesting is that during this period when Greece actually experienced deflation for 4 consecutive years, this red line doesn't move. And all the action is essentially happens in the green line, the fraction of people who expect positive inflation, and the yellow line. Let me now go back to Japan and show you how these fractions behave in Japan. So the top panel is the same core inflation and inflation rate in the period between 2003 and 2020. And so again, focus on this red line. Again, it shows you very small numbers, and the only movement is around the global financial crisis, which can again be probably linked to either oil prices or the fact that yen exchange rate appreciated like crazy because of the safe haven property. So it's I'm talking about the behavior of salient prices that people see in the news.
Dmitry?
Yes.
Dmitry, I'm sort of a bit confused still by what you mean a small number. So I see 20% of the people thinking that the inflation is going to be negative. And inflation is negative, but it's not crazy negative. Right? It's very close to zero anyway. So I don't know why you call it a small number. I can write a model where an epsilon proportion of people believing in something changes everything completely, right? And 20% is not epsilon; it's a lot of the population, right? So I don't know. And what is your metric to say that is a small number?
Well, so I guess no, it's an excellent question. This is an eyeballing exercise. What I mean, if you, I guess my prior, if you start from some kind of model with full information, rational expectations, then people kind of should know what the inflation rate is, and maybe they expect its behavior in the future. So this number should be close to 100% when there is like a persistent period with deflation.
I disagree with that because you are asking people about inflation. I don't know, maybe they are thinking about their own inflation, and there is a distribution of individual inflation. So some people experience positive inflation anyway, other people experience zero inflation, and rationally they tell you expect the price go down, and you say, no, my prices are going up. You see, so that is, well, I don't know. I think you need to, let me ask you a question related to that. So do you need the zero lower bound, or you need a lower bound?
Yeah. I mean, that's a fair question. I mean, think about like zero lower bound and nominal interest rate. I mean, we now transition from ZLB to ELB, right? We all call it effective lower bound. So here, I guess what's important is that something. I mean, it's not about zero, but it's this tendency that it's harder for them to kind of reduce to understand that prices can actually fall. Maybe, yeah. So this sort of. So for another related kind of story is about like downward nominal wage rigidity. So if you look at these distributions of weight changes, you also see like a huge spike at 0, but a few numbers negative, but very few. So then, yeah, you can like say it's 0 or be a little bit more flexible. So yes, I agree. It's 0 may not be like the most important observation. It's just like this asymmetry in the behavior. Okay, now let me show you yet another way in which we can see the presence of such a constraint. And so what I want to do, I want to understand how this distribution of cross-sectional distribution of inflation expectations, how different parts of it co-move with aggregate variables. And for example, with inflation itself. And so what we do, we estimate quantile regression, where we regress individual inflation expectations on a bunch of individual controls and on the realized inflation in the last 12 months. So we use, again, the Michigan Survey of Consumers. This is what we obtain. On the left-hand side, I present the intercept alpha. On the right-hand side, the slope coefficient beta that multiplies the realized inflation. So the key observation here is that the lower tail behaves very differently from the upper tail. And in particular, if you look at this 10th percentile, so the estimated slope coefficient is 0, meaning that the forecasts at this percentile do not come with realized inflation. And if you combine it with the fact that the intercept is estimated at 0, it just implies that inflation is stuck there at 0 or maybe around 0, but it's stuck there at the left tail. If you go up, for example, look at the 50th percentile, the median, the coefficient, the slope coefficient is 1, meaning that the forecasts react 1-to-1 to realized inflation, or related 1-to-1 to realized inflation. The intercept is something like 1.5, indicating that there is like a bias in inflation forecasts at the median, at 50th percentile. So this is like yet another way to look at the data that support the view of existence of this constraint. Now, I have been looking so far only at consumers and households. What about other types of agents in the economy? And so one important group of agents are professional forecasters who pay a great deal of attention to macroeconomy and in general should be very informed. And so let me just present you one piece of evidence. This is a histogram of their forecasts in gray and the realized inflation in red during the period between 1985 and 2020. And so you can see that these two histograms, they're not identical. So professional forecasters are humans, but they're much closer to each other. And these guys, they're able to expect deflation. So this is consistent with this idea that professional forecasters are more are quite informed. Now, firms. So one issue with firms is that there's way less data, good data with numerical inflation expectation for firms than for consumers. So what we do, we just present the data from this survey of firm and inflation expectations that Yuri and Olivier started running not so long ago. So, and this is the histogram of inflation expectations in just one quarter. It's like third quarter of 2020. This is just right after the lowest negative reading of inflation in the US during the COVID-19 pandemic. Okay, and again, it's like it's visible from this histogram. Again, you observe the same pattern that even during these difficult times when actual inflation is negative, nobody in this survey expects deflation. So this suggests that at least in this survey, firms look more, or firm managers look more like households, not like professional forecasters. And so the last empirical thing that I want to do today, I want to ask a question whether you can, whether you see any such behavior with other variables. And the short answer, no, there doesn't seem to be. But again, so it's open to interpretation. So here we look at the Michigan survey data again, and this is the histogram of the answers to the unemployment question. So this is a question asked whether people expect unemployment to change in the next 12 months, in which direction. And so quite a few people expect unemployment to go down. The same in nominal interest rates. There's also like some fraction of people who expect the interest rates to go down. You can look at other variables and you see like that for all of the other variables, there is some fraction of people that really expect negative values, unlike with inflation. Okay, so as a transition, let me just like speculate a little bit of whether there is anything that can explain the existence of such a constraint. And again, so these are just direction of thoughts. I will name a few hypotheses and move on and do something else. And so one thing is that we have evidence that people form beliefs based on their experience. And typically, probably except for Japan, we don't have a lot of experience with deflation. So we had the Great Depression, maybe a little bit during global financial crisis, but that's about it. So if this experience of positive inflation anchors your belief to be positive, maybe this is something that can generate such behavior. Second, sometimes we say that people think that inflation is bad. So if you ask in surveys what people think of inflation, the answer is always like it's one of the worst things ever. And so if people form their beliefs according to the worst possible case, like in their business literature, then they just like automatically should expect something positive. And finally, potentially, people may simplify their forecasts about the future by compressing all this like continuum of future expected inflation values into three groups: up, zero, or down. And if they assign essentially all the mass to up, maybe perhaps of this experience-based story, then you wouldn't see many answers below zero. But again, these are just speculations. What I want to do next, I want to be agnostic about the source of this constraint. I want to take this constraint literally, stick it into the standard 3 equation New Keynesian model, and show you what it produces. And so I will skip the part where people typically describe the agents, all the standard elements. Let me just mention non-standard elements. I will assume that there is going to be non-zero steady state inflation. Moreover, firms will fully index their prices to the steady state inflation. What it means is that when Calvo theory hits a firm manager and allows him to or her to reoptimize prices, he will reoptimize. But when she doesn't hit him, the firm manager still updates the price by the level of the steady state inflation. And more importantly, we introduced this zero lower bound on inflation expectations. First, we will assume that people are perfectly aware about the distribution of exogenous state variables in this economy, and the only problem that they have is with forecasting endogenous variables like inflation and output gap and the interest rate set by the central bank. And so, using the inflation example, let me explain the notation. I will use tilde on top of the variable to denote like forecasting functions that depend on future state variable, which ht plus s is some kind of information set in the future. And for brevity, I will never write this information sets anymore. But so I will use these forecasting functions. I will assume that they don't change over time. So it's like when you see something that you didn't expect, you're surprised, but you say, okay, I'm still confident that the way I forecast things is good, and you will continue. So it will not depend on the time when you're making this forecast. And the most importantly, pi tilde, this forecast inflation is going to be non-negative.
Dmitry, you have 10 minutes.
10. Okay, I'll try to speed up.
If it's 12, it's okay.
Okay, so now...
Okay, I'm in the annoying phase. So about the inflation, can you comment? So what I didn't understand. So you say in period T, so my expectation about the inflation in year 2000 is the same in 1991 and in 1999, independently of the shocks.
No, it's not.
Okay.
Let me clarify. That's an important point. So first, I say that this pi tilde is a function. Okay, is a function of this like history at t plus s, conditional on history at t. Then what essentially I say, okay, so I don't like to carry around this histories notation, so I still kind of in my mind keep the fact that pi tilde is a function of these shocks, but I will not write explicitly that there are shocks. And so what I'm saying is that this forecasting function that depends on the shocks, it just doesn't change over time. So if you're trying to forecast inflation for 2020, so you in 2000 you have some function that tells you that depending on the realization of all of the shocks between 2000 and 2020, it will be this. Then you move to 2010. And so this function, it doesn't change. It's still this function of the same shocks. So maybe the shocks kind of evolved a little bit. So you go into this like tree of possibilities. So you do take that into account, but the function, it doesn't change. So I mean, this is kind of consistent.
But the notation is a bit confusing because it sounds like, you know, you can have the pi tilde t of t plus s. It seems to be the same as pi tilde of t plus 1 of t plus s.
Oh yeah, so this is exactly what I'm saying, but I'm saying that this is it's fine because this pi tilde is a function.
Okay.
It's a function. I mean, yes, you learn the realization of certain shock over this one period, but it's fine. It's just like it's an argument in this function, this like realization of the shock. I can talk more about this, but I think this part is defensible. Okay, so let me speed up. When working with such a model, you have to be very careful because the realized equilibrium variables, they are actually going to be different from what people expect. So unlike in standard three equation New Keynesian model with full information rational expectations, you will have two sets of equations. One set of equation will describe contemporaneous determination of contemporaneous variables like output gap, interest rate, inflation. And the second set of inflation will be almost the same, but applied to future forecasted variables. So very quickly, this is the standard Euler equation, standard Taylor rule with the zero lower bound on nominal interest rate. And finally, this is almost standard Phillips curve. But because expectations are not rational, if you build this equation from micro foundations, you cannot perform this like very last step when you fold this equation and you obtain this beautiful expression where inflation depends on output gap plus next period expected inflation, because you cannot fold this infinite sum. So instead, you have to actually take care of all of this expected kind of variables, forecasted variables. So the same set of equation applies to like future forecast variables, except for the Phillips curve, where we say like, okay, here where the zero lower bound on inflation expectation comes in. So inflation, if the inflation expectation is positive, it's the same formula. But if somehow this formula tells you that it should be negative, something clicks in your head and you don't choose negative number, you choose zero.
Dmitry, but this is common for all agents. So there is just one information set for everybody. I don't need
yes,
to.
Yes. Toby, absolutely correct. I should have mentioned that. The assumption is like this is like representative agent economy. So here, the households, the firms, like whoever prices the interest rate, they're all the same guys. I mean, this is there is no dispersion in expectation. So this is essentially the simplest case I took to illustrate the consequences of the zero lower bound on inflation expectations. Okay, last thing, there is the uncertainty in this model, and I introduced it through the standard Egerton and Woodford trick. In time zero, there is a negative shock to the natural real interest rate that reverts back to normal with some probability mu. And so here I just plotted one sample pass of this natural real interest rate. Okay, so but why do I need this particular structure? First, because it makes me possible to solve this model by paper and pencil. But more than that, I can replace all the formulas with just few diagrams. And let me start with the rational expectations case and what it is here. So essentially, I need to solve this model for what will happen after this shock subsides. And it is very easy. Output gap returns to zero. Inflation returns to its target, because this model doesn't have endogenous state variables. So the only non-trivial thing is to determine what happens in this low state when the natural real interest rate is low. And so this is what this diagram is about. I'm trying, so on the x-axis, we have output gap in this low state. On the y-axis, I have pi in this low state. So upward sloping curve is this Phillips curve. It's just this positive relationship between inflation and output gap. The orange piecewise linear line is the Euler equation. So this downward sloping part is standard because higher inflation means that central bank increases the interest rate via Taylor rule. It depresses aggregate demand, output falls. But when inflation becomes sufficiently low, the Taylor rule prescribes the central bank to set the interest rate to zero. And the central bank does not react to inflation changes anymore. And so the only thing that happens is that inflation actually is linked here in this uncertainty structure to future inflation. So higher inflation implies higher inflation expectations. And this reduces a real interest rate, boosts the output. So this is why we have this like hockey stick a little bit. So when the size of the negative shock is zero, so the intersection is at this point at zero output gap and inflation target pi bar. Now, if the shock is slightly bigger, the Euler equation moves to the left. But we are still in this downward sloping part of the Euler equation. So this black dot determines the output gap and inflation. Even bigger shock brings the economy to the zero lower bound. So we on the intersection is on the upward sloping part of the Euler equation. Finally, if this shock is even bigger, this intersection is such that inflation is negative. Okay, and this is all like rational expectations equilibrium. So with the zero lower bound on inflation expectations, we prohibit not actual inflation, but expected inflation to be zero. So let me now redraw the same diagram where on the X and Y axis, I have output gap and inflation with tildes. Those that are, forecast variables. They will probably never realize, but still people solve for them in their heads. And so the key difference is that Philippe's curve has this like flat part at zero, which is the zero lower bound and inflation expectations. And so if you compare this intersection over here to the rational expectations equilibrium intersection, you observe that inflation is much lower, output gap more negative than here. Of course, these variables are only like forecast variables. You need to plot yet another diagram to arrive at the realized inflation and output gap. I'll just like plot on this diagram where the realized inflation and output gap will be. And they will be here in point B. And the reason for that is that realized output gap will be equal to forecast output gap. And this is like, if you look at this Euler equation, this is all due to the fact that in the zero lower bound on the nominal interest rate, actual inflation does not affect output gap. So it's all about your expectation about the future. So the realized output gap is determined by expectations about future in the same way the forecast output gap is determined by expectation of yet a more distant future. But given the structure of the economy, it's the same. And realized inflation doesn't feature any constraints, so it has to be on the Philippe's curve, which features negative values of inflation. So the realized values will be here at point B, which is still to the right and above point C, which is rational expectations equilibrium. So all this stuff is qualitative, but I mean, by varying the slopes of these variables, you can make point C essentially slide to infinity and point B be stuck here and not go to this infinity with this crazy deflationary spiral process. Okay, so in the interest of time, let me start just naming the results, and I will finish soon.
It
So
should be done in 1-2 minutes. Is it okay?
Yeah.
Thanks.
So what we show is that in the presence of such a constraint, forward guidance is less powerful, and so this is just the diagram that tells you how the curve shifts from dashed lines to solid lines in rational expectations. So you move from this point on the left to this point on the right. So essentially a strong response of promising future zero interest rates. In our economy, one part of this channel is shut down, which is like a shift in the Philippe's curve. And again, why this happens? Because inflation expectation doesn't move. It wants to go from -5% to -3%, but both of these values are below zero. So when something changes from -5 to -3, people don't react. There is still reaction through the Euler equation, but it just tells you that the unconventional policy like forward guidance is less effective. So there are a bunch of other implications that are quite curious, like negative interest rates are less powerful, communication policies. So if you're able to explain to people that actually you live in this like deflationary world, and they start changing finally their expectations to negative, it can deepen the recession. So there is an interesting puzzle in this new Keynesian literature that negative supply shocks are actually expansionary at the zero lower bound on nominal interest rate. with the zero lower bound on inflation expectations, they are no longer expansionary. And finally, the last thing is the question of optimal inflation target. So it's like this model presents with an interesting trade-off. On the one hand, at the ZOB on inflation expectations, these unconventional policies are less effective. So it's like an argument to increase inflation targets, so you avoid this all this ZOB things. But on the other hand, ZOB on nominal interest rate is no longer so devastating when ZOB on inflation expectations also binds. So and this model presents with like an interesting trade-off that can be analyzed to choose the optimal inflation target. Okay, so let me stop here. Let me just say that fact, consumers and perhaps firms don't expect deflation, and this has interest in macroeconomic implications. Thank you.
Okay, so the key question in macro is what determines the nominal anchor of an economy. Okay, so this is where this paper contributes. And so why is it a very important question? Because, you know, it's a question that is related to what led to the great inflation of the 70s. Why is Japan and maybe also the euro area trapped in the effective lower bound with low inflation regime? And we have a textbook answer to that, which is the textbook Eugenesian answer. The textbook Eugenesian answer is that it's an active monetary policy which is committed to the target that delivers the nominal anchor of an economy. Okay, and then if you think of what are the possible sources of deviation from target in this textbook answer, those are, you know, a combination of shocks which are going to impact inflation expectations and also policy mistakes. Okay? For instance, in the 70s, you have oil price shocks, and then the policy failed to be contractionary enough to combat the associated inflation pressure. And now if you think of Japan and the euro area, you had financial shocks, and then policy failed to pretty become expansionary enough to exit the trend. Okay? And so those, you know, this textbook answer is a very influential view of central bank, how monetary policy should be conducted. But there's you know, some limitation. So we might want to go beyond that textbook. Okay? So some of the predictions that are with recent experience were mentioned this morning, but the deflation spiral that Dmitriy, but also Olivier mentioned this morning, is not something that happened during the Great Recession. So this has been the missing deflation puzzle. For arguments is super powerful in these models, and it's not apparently not the case. So this puzzle, and also more recently, you know, one strong prediction of this new Keynesian model is that economies that are above financial will create inflationary pressure. And if you think of the US, for instance, which were, you know, at very low unemployment rate before the COVID crisis, without having any inflation or significant inflationary pressure, you know, this is at odds again with this Keynesian model prediction. Okay, and so there's a common reason for all these puzzles, which is that inflation expectations are too powerful in this setup. Okay, and so there are several extensions to try to mitigate that channel. And, you know, you can group them, I think, overall into two categories. So one is the model with heterogeneous agents and another one, which is of course, you know, complementary to that one, is you introduce imperfect information and some form of predictive. So that paper, the paper by Dmitriy and Yuri, are of course falling to that second category. Okay, and I think it's an important research agenda because overall, the important question, at least for monetary policymakers, is that should central banks buy less of deflation, less of inflation, or less of both compared to what the new Keynesian setup predicts or recommends. Okay, so this is where this paper contributes again, and so there's two main contributions, as Dmitry very clearly emphasized. So there's a new fact from survey data. The new fact is that households do not expect deflation even when it happens. And this, evidence is to be striking, even though it can be debated, but very striking. It's robust across periods and countries. And then they introduce a behavioral bias in another West standard equation model, where agents cannot expect deflation. Okay, and so they have several results. One, there's no deflation spiral, somehow mechanically. Then they also kill the type of equilibrium where you can be stuck, the economy can be stuck at the trap with interest rate at 0 and inflation below the target. They also have that for guidance is much less powerful than standard Keynesian model. And the key to all these results is that at the trap, households are too optimistic about future inflation. So inflation should be, at the trap should be negative, and you should expect a negative profile for inflation, or profile where inflation will converge to the target, but should be negative for some time. And instead of that, agents expect that inflation is going to be at 0, so above what the rational expectation equilibrium. So the implication is that deflation is less of an issue compared to the standard Keynesian setup, even though for guidance is less effective. Okay, so I have a few comments. The first comment is I think it's been suggested by Tobias already. Everybody, the bias that is this constraint on expectation applies to everybody. Okay, so it's common to every household and firm. And you can think that maybe some agents are better at forecasting inflation than others, and this has been shown, for instance, by Bocconi and others, where they show that the lower your cognitive limit, the better you are at forecasting inflation. And so, if you look at households first, well, this is, of course, there's some disparities, but something that is really striking is that almost no household expect deflation. This is also the case in Japan. Okay, so there's some form of homogeneity there. Nobody is below 0, right? So I think this is very supportive of the assumption that it makes. But then if you look at firm, there's very few evidence, and it's for firm only. Sorry, it's for the US only. And so you might think that maybe it takes time for firms to learn that they are really in a situation where inflation is going to be significant. And so I would like, and maybe it's not possible, to see more evidence on firms in Japan, where I doubt that no firm expect that there's going to be deflation in Japan. Maybe this is so, but I'd like to see the evidence. And if you look at professional forecasters, as Dmitry showed, that they are a little bit better at forecasting deflation. So maybe firms are a little bit closer to professional forecasters than to households. Recent papers. So, in any case, maybe if you don't have the evidence, maybe you can relax the assumption that firms share the same cognitive bias that households. I don't know if you need that to get your result. The second one is on the asymmetry of inflation expectation. So, first of all, in the data, as you said, the fears of inflation are more important than the fears of deflation. Maybe it would be nice to look, so you only look at the cross-sectional distribution of point forecast. It would be nice maybe to have, the same type of exercise. If you look at the probabilistic distribution, survey of probability distribution, you have, for instance, the New York Fed survey that does that. And see whether it's true that for households they react less. The probability of, so for instance, is there zero probability of deflation? Maybe not. And second of all, if there is some positive probability attached to deflation, does that react very, very little to variation in inflation or not? So that would be something. As you mentioned as well, we know from this inflation paper by Bocconi and Nagel that expense of inflation matters. And so here somehow you show that the expense of deflation doesn't matter much. If you think of Japan, years of deflation does not make you thinking that there's going to be deflation. So yeah, is there a way to test the fact that there's no experience of deflation does not matter or matter less than experience of inflation? That would be interesting. In the model, so somehow the form of cognitive bias that you have is a combination of the asymmetry in inflation expectation that was by Kerry and the discontinuity in inflation expectation that we have in our paper with Juan Gauthier and Eric Mangus. And so again, what it makes is what it does is that at the trap inflation expectations tied up at 0 and above the deflationary bias. But above the trap, the inflation expectation channel is standard. Okay. So again, a bit by construction that mitigates the risk of deflation, but not the risk of inflation. And so, I want to emphasize really that this asymmetry somehow, puts a lot of weight on the risk of deflation compared to inflation. And maybe you want to discuss more what would be the optimal monetary policy in that context. For instance, you would expect that maybe one policy option would be to have more aggressive forward guidance so that you create positive inflation expectation above 0, and that would reduce the trap, the length of the trap even more. And of course, there's a cost to that because you create more inflation, and so you would like to know whether this type of policy is optimal or not. And I think that it will be also interesting because it will allow you to differentiate yourself compared to other new Keynesian models that have also introduced bias. For instance, the recent contribution by Banque, where they discuss, optimal monetary policy and stuff like that. The third comment that I want to make is maybe you have other biases and margins where the inflation expectation channel should play a role. So here, what I show you is realized inflation in the US, that's the blue line, and expected inflation of households, the 5 years expected inflation of households. 1999 now. And so what you see, so the dark line here, the dark dashed line is %. So what you see is that expected inflation on average was target that was
we are losing you, Philippe.
Okay.
Sorry, the connection is not very good. In any case, you are starting to run out of time.
Okay,
so
okay. I'm gonna finish. Can you hear me or?
Now we can hear you. Yeah,
Okay.
but it goes.
So I'm gonna finish with that comment. But yeah, you see that expected inflation was above 2%. Okay, and so the question is how it's what will happen if you put that upward bias in the model. Okay? And so one way to do that is to assume that households consume more when their expected inflation is above their average expectation, which is above 2%. And so and that the experience of deflation will lower inflation compared to this average inflation expectation that could have an impact on aggregate demands. And so as we know also, forward guidance can have an impact on average inflation expectation, as shown by inflation. So maybe this could give you more leeway to inflation expectation, even if you have this lower bound on inflation expectation. That comment and wrap up. Say that it's a very nice paper. You have a striking fact using several long-standing survey households, an elegant new Keynesian model featuring a new cognitive constraint at the effective lower bound. And again, if you go back to the fundamental question of reassessing the risk of deflation and inflation compared to the Keynesian model, I think this paper clearly says that there's lower fear of deflation, even though policy to escape the trap are less powerful. An implication is, the fact that the average inflation targeting that has been adopted by the Fed is probably not so great because, the logic of it is really to avoid the cost of the deflation. But that being said, I think it's a nice conclusion, but maybe there's another question that is not addressed and that remains an open question, which is what are the risks of deflation and inflation under bias, and we have asymmetry that was involved. Thanks.
Thanks. Thanks a lot. So, Dmitry, I don't know if you want to answer. I don't know if there are other questions from the. Maybe Dmitry, you can answer to the discussion.
Can I just?
Yeah, sure.
I just had a quick look at the New York Fed's survey of consumer expectations. So they have an histogram for inflation going forward, and I computed that histogram for 12 months expectations just for one date in 2013, where I happened to have the data, and it seems I was going to share my screen, but I don't think I can do that. But so I'm not sure you can see this, but this is what it looks like. So there's quite a mass below zero. So I think that just speaks to the fact that we want to actually we don't want to just look at point forecasts. We want to look at, I mean, then there's all sorts of problems, perhaps with consumer, probabilistic questions and all of that. But maybe that just underlines the fact that we want to look at probability distributions. But then maybe those are biased too, but it doesn't seem that they have this hard constraint at zero. So that was the 25th percentile that I just showed to you there. The question comes in quartile bids, basically. So that was the 25th bottom percentile of the individual forecast distribution histogram of that. And there seem to be plenty of people who seem to be putting that quartile below zero.
So
could I ask a question as well?
Sure.
Yeah, I was going to ask, so if there's this asymmetry in the distribution of inflation expectations, and if people are forming their expectations over different variables jointly, then in principle you would see an asymmetry in the forecasts of other macro variables as well. So have you tried looking at, whether do we see any kind of asymmetry in those distributions that would kind of line up with this type of break in the Phillips curve?
Well, I mean, okay, great question. So let me wait for maybe more questions and then I will respond.
Yeah, I had just one or two clarification questions on the model. Is it the case that for a given state today, if the path that follows is such that inflation is always non-negative, then agents' expectations coincide with rational expectations on this path? And then if it is the case that inflation, on the path that follows inflation is negative at some point, then you can rank inflation expectations of the agents and rational inflation in your model and realize inflation under rational expectations, in the sense that the former is going to be always above the latter, because if you cannot expect negative future inflation, then today's ex-ante real long-term interest rate is going to be lower than under rational expectations, meaning that it may, increase actual realized inflation.
So I just a quick response. So maybe I misunderstood, but I thought it would always put more upward pressure on the realized inflation. But maybe what you're saying is an experiment where
upward pressure and then downward pressure on the ex-ante real long-term interest rates.
Yeah.
Meaning that more support for the economy and therefore higher actual realized inflation.
Exactly. Yeah, that's a source of explanation of missing disinflation in this kind of model.
Okay, so the question is, can you show that? Do you obtain a formal result that this is always the case?
Well, the graph is essentially.
Okay, I meant analytical results.
Yeah, and so there are formulas.
Okay.
So these graphs are not made up. There are formulas. So yeah.
Okay, thank you.
So shall I start answering, because I think it will take. Okay, so let me be brief. And first of all, I thank Philippe for carefully reading our paper and making so many comments. Let me agree with all of them. They're great. I mean, looking at firms in Japan in particular, this is something that we can do. It's just like, we need some data, but it's doable. This is really a great suggestion, as all of the other suggestions. So we just like need to like put them on the paper immediately. Now, let me jump to Tobias' observation. So I didn't quite understand what that histogram was, but that you showed us, because you explained it too fast.
It's the 25th percentile of individual in forecast distributions for 12-month inflation as a histogram across individuals. So it's the histogram across individuals of that 25th percentile of the individual's forecast distribution. Now, I think the question might ask those directly, or they inferred from some finer distribution.
There are two things that I think are kind of important about New York Fed survey. First, it's excellent. It's like panel consumer survey, which Michigan survey of consumer is not. And it allows us to answer like many great questions. Now, there is a risk with a panel survey, and there is research about that. So as participants participate more and more in the panel, they become professional forecasters. So their forecasts become indistinguishable from professional forecasters.
This histogram was for the first date, so I believe that's probably the first time these people participate, but I don't know. I mean, I did this quickly, so I just wanted to say it's perhaps worth looking into. So they should have been participating.
And second, this like a probabilistic forecast question. I mean, it can potentially motivate people to say something negative just to please. I mean, this to please the people who conduct this survey. I mean, this like when they see that, well, I mean, here's -1, -2. There is a anyway, but there are certain important kind of caveats with this like panel surveys. Okay, so and Olivier asked about joint distribution. I mean, it's kind of natural that when you have a kink on inflation expectation, you have to also have a kink on output gap, for example, or in some other variables. There is not going to be like constraint on output gap. Output gap can still be negative. It will probably, if you look at the distribution, and if this effect is there, then it of course joint distribution will kind of be affected by this constraint on inflation expectation. This is something that that can be checked with some like good quality data on output growth or unemployment rate. It's just like in the Michigan survey, the answer is only like up, down, or no change about unemployment rate. And another Olivier asked a great question, but I think I already said a few comments about them. Again, thank you so much for your comments, questions, and especially to Philippe and to the organizers.